Yeah, my name is Poppaea. Today I'm gonna talk about using Sigstore provenance as like an indicator for threat hunting, and I'm going to illustrate this with a case study into North Korean state-sponsored activity that we at Stacklok detected back in September. So the focus here is on threat analysis rather than Sigstore internals, because everyone in this room knows more about that than me, so I'll talk about something I do know about, which is the kind of investigative side. So quick, who am I? Yeah, I'm a security researcher at Stacklok. Been doing that for about 4 months. Just like mostly focusing on malicious open source packages, hunting them, that kind of thing, detecting them a bit better. Before that, I spent about 3 years with Secure, focusing on more of the endpoint detection side of things and threat hunting there. And before that, I just studied physics, basically. And I live in London. So, quick agenda. Going to talk about the motivations. So, just kind of open source supply chain attacks, why they're important. Well, we know they're important, but yeah, just discuss that a bit, the context, how package provenance is useful for assessing supply chain risk, especially Sigstore provenance, and then kind of go into some threat hunting and detection and using Sigstore provenance as a signal, before diving into the DPRK, Advanced Persistent Threat case study there, going to the attack chain, and then just wrapping up. So, starting with the motivation, almost all like modern software relies on some open source packages, so npm, PyPI, which I know how to pronounce correctly now, which is good to know. I was definitely going to say that wrong before. PyPI, Maven creates, stealing some stats from Sonotype's supply chain report. There's been 4.5 trillion requests for npm packages this year, about 0.5 trillion for PyPI. So yeah, attackers are increasingly exploiting the interconnectedness of the supply chain and the trust-based nature of it to distribute malware. And yeah, I should mention here that I'm focusing on malware in open source packages rather than vulnerabilities in the open source supply chain, because of course they're different things. And I feel like with malware, you can, in open source packages, you can put this into two broad categories. So legitimate packages that have been hijacked to include some kind of malicious code. So this is your maintainer takeovers, your XZ utils kind of situation. So this is, and then the other one is just new malicious packages. So an attacker just creates something and typo squats it so it looks, it's like pandas with a Z rather than an S or whatever. But the former is typically more dangerous because it's got a larger blast radius, but it's much harder to detect. But then, yeah, one of the other options as well is to include your new package or your malicious, well, whatever it is, whatever malicious package, include it as a dependency in one of these kind of disgusting dependency graphs that we see here. So, especially for NPM, transitive dependencies are a really, really big problem here because it really increases the attack surface. So yeah, this is just a random package that I found, and this is the deps.dev graph for that. So it had 500 direct dependencies, but if we include the indirect dependencies, so the transitive dependencies, it brings in this mess, so just thousands of packages more. And obviously nobody's really going to consider all of the transitive dependencies they're bringing in. So yeah, there's been an exponential growth in open source supply chain attacks, and it's really easy to create throwaway accounts on the package management registries and just publish whatever you like, and then stuff gets taken down because people like me report it, but then you can just create another account, so it's fine. But APT groups have been taking advantage of this, of course, and especially nation-state groups such as the North Korean state-sponsored groups. So the example on the screen is Japan's CSERT attributed some PyPI activity to Lazarus Group, which is probably the most well-known North Korean group. And just, do some self-promo. This is some activity that we were able to attribute to North Korea earlier this year, separate to the one that I'm going to discuss now, and actually a separate North Korean group. And then the final point here is that package origin is self-declarative and it doesn't tend to be verified by the package registries. So this leads on to why package provenance is important. So, as I'm sure everyone here appreciates, ensuring integrity and authenticity is really critical to the software supply chain, and source of origin verification and build provenance plays a key role there. But like moving kind of the focus onto attacks, there's a whole suite of package confusion attacks, including things like starjacking and typo squatting. So attackers will, of course, be wanting to imitate kind of high reputation, trusted packages to try and mislead people into using that package. And this is where provenance can be a key differentiator, but in combination with other signals, I should say, because provenance on its own is not an indicator of safety or trust, or vice versa. So just to go into starjacking a little bit in more detail, this is a pretty common attack method used by attackers just to hijack the metadata of a high reputation project. So often it's coupled with typo squatting, so seeking a name that's got a slight variation typographically to something that's well known. So if we come back to this idea that the repository link is self-declarative, package managers like NPM will helpfully link all of the popularity statistics for the GitHub repository to the NPM page. So on the left, I have like a legitimate, I think it's something to do with Discord, called distube. So that's a legitimate package. The one on the right is a malicious package, but you can see they've got the exact same README. It's probably not very easy to see, but the versioning is very similar. The number of files is very similar, like pull requests, issues, whatever. So maybe to first glance, it doesn't look too dodgy, but yeah, it's kind of hard to sense these attacks just by looking at it on the NPM page. But what's nice is that NPM does have the Sigstore provenance displayed on packages where it's been built and signed with Sigstore. So that's nice, and you can see the transparency log entry, and you've got all the links there. So yeah, then moving on to the North Korean case focus. This is a malicious package called ESLint scope util. So this is linked to the ESLint scope repository, but strangely enough, the README is actually Etherscan API, but I think this is just a mistake by the attacker, because they also did a starjacking attack on Etherscan API, so I think it was like, copy paste, but just a point of interest, I suppose. So then, yeah, kind of introducing, so Trusty, as Luke mentioned earlier, is our package risk analysis platform, and this on the right is the Trusty page for the legitimate ESLint scope. So this package actually has a provenance record that's signed by Sigstore, which confirms its source of origin, and Trusty displays a verifiable chain of trust back to the source code, so you know that the package is what it says it is. And this, yeah, we have other methods of provenance verification as a fallback, but Sigstore is what we consider the ideal provenance verification, because this is a cryptographically strong link. And based on, I did a few stats just based on our database of packages, and I found that actually around 1.5% of the NPM packages that we had on record have Sigstore provenance. So yeah, it would be nice to get that wider adoption there. And so yeah, this is a strong link which can help developers make better choices to filter out suspicious or unverified packages. And this is like mildly confusing because this is from the point of view of the malicious package. But we can highlight the starjacking risk, and we can see that it's got a possible starjacking match, but the match is the benign one, and you can see it's signed with Sigstore, which is nice. So then kind of thinking about threat hunting hypotheses. This is a little bit hand-wavy, but I suppose just walk with me. We could argue that packages with Sigstore provenance tend to be well maintained. They tend, like somebody that's going to bother to do that will tend to be maybe like a decent contributor. So if these tend to be trusted high reputation projects, then, and of course there'll be exceptions, this is going to be attractive for starjacking. So what I did was just kind of hunted for all packages that did not have the same name as a package that had a legitimate claim to a Sigstore-linked repository. So yeah, ones that were spoofing a claim. And yeah, just use that as kind of a starting off point to do some more, like aggregation and ordering, chain it with some other signals. And yeah, it's pretty nice. Dropped out a few interesting things. This is obviously going to be high noise. It's not something we would automate to a rule, but it's nice to have as a hypothesis. So as I mentioned earlier, provenance on its own is not a signal of security or even quality, because malware could have legitimate provenance claim, or secure high quality projects might just not have a provenance record. But yeah, we want to chain this threat hunt with other factors, such as maybe some kind of scoring for the activity of a package, the reputation of its contributors and maintainers, some static code checks looking for things like obfuscated code, some kind of modeling on whether the name could be possibly a typo squat. So you might chain it and have a situation where a package has a failed provenance with a very similar name to a high reputation project that has a verified source of origin. And then you can say, this is probably a starjacking attack. And then just the graph that I have there is, also Luke mentioned this earlier, the reputation graph. So the node in the center is the repository, the GitHub repository. And the two main nodes branching off are the two packages, and the edge connecting them is weighted by the provenance, and I've color-coded it by the provenance. So we've got a nice green one for the Sigstore verified package, and we've got a horrible red for the one with the failed provenance. And the other nodes are contributors, and the coloring there is just based on some activity metrics that we use. So moving on to the attack chain itself. It starts with, like so many things, it starts with social engineering. So in this case, the threat actors made contact with developers, or people that wanted to be developers, generally over LinkedIn, and they would kind of lure them with fake jobs, and they would send them a GitHub link and say, please clone this, please run it. This is a coding challenge for this job. So as soon as you run the repository, it will invoke a direct dependency, which is this malicious NPM package. This NPM package contains some obfuscated JavaScript, which is actually a piece of malware that's been dubbed Beavertail. This is like an info stealer and a loader. I'll go into it in more detail. This downloads then a Python multi-stage piece of malware called a visible threat. And this attack chain was first seen about a year ago, and it was kind of first documented by Palo Alto Unit 42. There's been some variations in the meantime, such as the threat actors also packaged up the Beavertail and Invisible Ferret as a Qt GUI variant, things like MirrorTalk, like a fake app. This has been able to be attributed to state actors associated with North Korea due to just the characteristics of the attack chain and the infrastructure used, because a lot of the times they reuse the infrastructure, and they're not not very stealthy, really. So, first step is social engineering. This is a known tactic of North Korean state-sponsored actors to use these bogus job ads and interviews. So what was interesting about this is it was targeted particularly towards kind of Web3 and decentralized finance. So they tended to be themed on like NFTs and Ethereum and whatnot. So, you know, they're aiming to maximize the likelihood of stealing cryptocurrencies and getting footholds into interesting environments for future financial gain, because that tends to be the goal of North Korean groups. I should say this one on the right is, which I don't know how visible that is, but it's basically the GitHub profile of the user that put up the repository that I found. So the repository is called NFT Marketplace, and then the user is called Power Exchange, and it's all about like devs building scroll network. So this repository pulls in one of the starjacking packages as a dependency. So kind of nested under a few folders, there's a script that has a call to a function within the malicious npm package. So as soon as you run npm run dev or build or start, it would run server.js, which would require app.js, which would call API features. So it was kind of nested for a few different things. But the malicious package itself is, so I should also say, by the way, this is not, so this is the Etherscan API one, because I couldn't find, so this is the only one where I could actually find a repository that's still live on GitHub for it. But it's pretty much the same kind of, infection vector as I expected for the one that was starjacking the Sigstore verified one. But yes, so this is basically a complete copy of the Etherscan API legitimate package, but they've just added one file in it called hashblob.js, which seems, seems reasonable, hashblob.js. But actually it's this horribly obfuscated file, which has been obfuscated with the JavaScript obfuscator, which is very easy to just remove the first layer of. So I'll go into that in a moment. But I suppose it's worth making the point that since the malicious functionality was in the dependent package and not in the project that was directly distributed to the targets, this basic evasion is actually quite effective, because this abstracts the malicious functionality away from the user and away from any security tooling. So even though it's not that sophisticated, it does work. So the obfuscated JavaScript itself, this is the Beavertail loader and stealer. So it has a dual purpose, stealing information, stealing cryptocurrencies, and also downloading further malware. So this is a cross-platform stealer. It's got functionality for Windows, Linux, and Mac, and it seems to be particularly focused on Mac, actually, which is interesting. So what it will do is look for things like credentials from sensitive browser databases. It will look for particular cryptocurrency browser extensions, so looking for anything that can get them access to cryptocurrency wallets. And also had quite a few Mac-specific things, like looking at iCloud keychain and Solana configuration files that would be on disk in Mac. And it would just post these out to the C2 server over HTTP. The stealing features here are quite consistent with the ongoing financial interests of North Korea, the North Korean threat actors. And then the second functionality is just downloading a second stage. So the C2 server that we see is a known North Korean C2 server. And this is what the code looks like after you just remove that first layer of obfuscation. It's still got, like hexadigit functions and things like that, and you don't really need to deobfuscate it to understand what it's doing. So then the next stage is the Python malware that's downloaded. So this is a multiple stage malware. So we've got stage 1, where it downloads more stages based on the host operating system. Stage 2, it implements some remote access Trojan and backdoor functionality. And stage 3 is just even more information stealing because we didn't do enough already. So the first thing that we see, so this is the file that's downloaded by Beavertail, and yeah, this is just some nasty Python basically, but it's very easy to see what it's doing because it's just an obfuscated script. So it's been string's been reversed, base 64 encoded, and it's been compressed with zlib. So I did this once or twice, and then I realized it wasn't a once or twice, so I wrote a script, and then it was 50 layers of that exact thing, so glad I wrote a script. I won't show the script you get at the end because it's not particularly interesting. It literally just downloads the next stage. So the file called n2pay is where the meat is really. This is also obfuscated the same way, so just use the same script again, and you out pops the script, out pops the actual functionality. So this actually, again, I don't know how, that's really not visible, but what's on screen is some functionality that it has to do machine fingerprinting. So it's looking at the IP address of the victim machine, looking at where it is in the world, location, like geolocation data. It's got a lot of functionality for executing commands from the operator and the C2 server. It's also got extensive key logging and clipboard logging functionality, and it can also download AnyDesk in case they want to have GUI access, and executing a tertiary component, so the browser stealer. So this is the browser stealer. Something that I thought was quite interesting, so it's almost 500 lines, and it's very well documented. It's got doc strings, it's got comments, but I actually think it kind of gives me, I kind of feel like they've generated it with AI, which is interesting. So I don't see why, because they've got comments in there that are really unnecessary, and it's like, why would you comment your malware anyway? But yeah, so I thought it was just a point of interest there that they probably used AI to generate it. Yeah, so that's that. Key takeaways, as I mentioned, in this case, the additional malicious code was kicked off the infection chain, was abstracted away from inspection by the user and automated security tools. In this case, involved a relatively simple kind of direct dependency. The complexity and resultant risk increases exponentially when you consider transitive dependencies. And nested dependencies just increase the difficulty of identifying threats. Yeah, my use of Sigstore provenance is really basic. Yeah, and provenance isn't a silver bullet at all. I think there's certainly more I could do there, so I'm gonna look and see more kind of threat hunting and security research we could do based on the data we have from Sigstore. And then I suppose it just emphasized to me how we need broader adoption of Sigstore. And PyPI Sigstore is coming. Excited for that. That'll be good. And learned today about Ruby and Maven in the works as well. So that's great. But yeah, that's everything I have. I'm sorry, I kind of rushed through that a bit. Thanks.